Strategic installation for maximum yield. The ancient clay jar irrigation method that turns dry soil into a productive garden. The quiet irrigation technology that fed civilizations before pipes and pumps existed. Long before plastic drip lines and electric pumps, farmers in some of the driest regions on Earth developed a remarkably simple irrigation technique that conserved water with extraordinary efficiency. Archaeologists have uncovered evidence of buried clay irrigation vessels across ancient agricultural regions stretching from North Africa to Central Asia. These vessels were not decorative artifacts or storage containers. They were irrigation tools designed to deliver water directly into the root zone of crops, while wasting almost nothing on evaporation. Today, this method is often referred to as Olla irrigation, named after the traditional clay vessels used for the system. The technology appears in multiple ancient farming traditions, including regions influenced by early irrigation knowledge in places like Persia and parts of early Mediterranean agriculture that flourished across the lands surrounding the Mediterranean Sea. The principle is deceptively simple. A porous clay jar is buried in the soil with its neck at or just above ground level. Water is poured into the jar, and over time the surrounding soil slowly pulls moisture through the clay walls by capillary action. The soil receives only the water it needs, directly where plant roots can absorb it. Unlike surface watering, which loses a large portion of moisture to sun and wind, this deep earth hydration technique places water precisely where plants need it most. The system can dramatically reduce water consumption while improving plant health and productivity. But achieving those results requires careful installation. The depth of the jar, the spacing between vessels, the design of the lid, and the selection of crops all determine whether the system becomes a powerful tool or simply another buried container in the soil. Understanding the strategic installation of these jars is the key to unlocking their full potential. Proper jar depth determines whether the system feeds root or wastes water. One of the most critical aspects of clay jar irrigation is determining the correct burial depth. If the jar sits too shallow in the soil, the moisture disperses near the surface, where evaporation quickly steals it away. If it sits too deep, the water may bypass the primary root zone of many crops. The ideal placement aligns the widest portion of the jar with the most active root region of the plants it serves. Most productive garden crops concentrate their feeder roots within the top 12 to 18 inches of soil. This zone contains the richest microbial activity and the highest oxygen levels, making it the most efficient area for nutrient uptake. To install the jar correctly, the gardener first excavates a hole deep enough to bury it, so that roughly 90% of its body lies below the surface while the neck remains accessible above ground. This usually means you're digging a hole between 10 and 14 inches deep, depending on the jar's size. Once the jar is placed into the hole, soil is packed firmly around the vessel to eliminate air gaps. This step is essential because the clay must remain in close contact with the surrounding soil for the capillary moisture exchange to function properly. When water is poured into the jar, the porous clay slowly releases moisture outward into the surrounding soil. The soil itself regulates the flow. When the surrounding earth is dry, water migrates outward rapidly. When the soil becomes moist, the flow slows dramatically. This self-regulating mechanism makes the system surprisingly efficient and forgiving. Strategic spacing between jars ensures roots compete less and harvests grow larger. Spacing between irrigation jars determines how effectively water spreads through the soil profile. Each jar creates a moisture halo in the surrounding earth, a roughly circular region where water gradually moves outward. In medium-textured garden soils, such as loam, this moisture zone often extends between 12 and 24 inches from the jar's centre. To take advantage of this distribution pattern, jars should typically be spaced between 2 and 3 feet apart. This allows the moisture zones to overlap slightly without causing excessive water saturation in any single area. When spacing is too wide, dry soil gaps appear between moisture zones, and plant roots struggle to reach water. When spacing is too tight, the soil may remain overly wet, reducing oxygen levels and encouraging root disease. A useful installation technique involves mapping the garden bed before digging the holes. By visualizing a grid where each jar supports a circular zone of hydration, gardeners can place plants around the perimeter of those zones so their roots naturally grow toward the moisture source. Tomatoes, peppers and eggplants often benefit from being planted roughly 12 inches from the jar's centre. This placement encourages roots to spread widely through the soil while still accessing reliable water. Over time, the plants develop deeper and more resilient root systems than those produced by frequent surface watering. The lid and neck placement quite determines how much water the system saves. One of the most overlooked components of clay jar irrigation is the lid. Without proper coverage, the jar becomes vulnerable to evaporation, debris contamination and insect intrusion. Water exposed to open air inside the jar can evaporate surprisingly quickly, especially in hot climates where the soil itself may remain cool while the exposed water surface warms under sunlight. A simple lid solves this problem. Traditional farmers often used flat stones, clay plates or wooden covers placed directly over the jar's opening. Modern gardeners frequently adapt this idea with ceramic saucers or tight-fitting caps that allow easy access for refilling while protecting the water supply. The lid also prevents leaves, soil particles and insects from falling into the jar. Debris accumulation inside the vessel can create stagnant conditions that encourage algae growth or bacterial buildup. Keeping the jar clean ensures that the water moving through the clay walls remains fresh and oxygenated. Neck placement also matters. Ideally, the neck of the jar should sit slightly above the soil surface. This prevents soil runoff during rainstorms from entering the container. A raised neck combined with a secure lid transforms the jar into a sealed underground reservoir, feeding moisture slowly into the soil. Understanding how soil physics controls the movement of water from the jar. Clay jar irrigation works because soil behaves like a giant sponge composed of microscopic channels and pore spaces. When water moves from the jar into the surrounding soil, it does not simply flow outward randomly. Instead, it follows capillary pathways formed by soil particles. These pathways draw water toward dry areas where plant roots are actively extracting moisture. The process resembles the way a paper towel absorbs water from a spilled glass. The fibers in the towel pull water through tiny channels until the entire sheet becomes evenly damp. Soil behaves the same way. When plant roots absorb water near the edge of the moisture halo, the surrounding soil dries slightly. This dryness creates a suction effect that pulls more water from the jar through the clay wall. The system therefore operates on demand rather than constant release. This self-adjusting behavior makes clay jar irrigation remarkably efficient compared to surface watering, which often floods soil faster than plants can absorb the moisture. Identifying the crops that benefit most from deep earth hydration systems. Not every crop responds equally to buried irrigation jars. Plants with deep or moderately deep root systems tend to benefit the most because they can reach the moisture zone surrounding the jar. Vegetables such as tomatoes, peppers, squash, cucumbers and eggplants respond exceptionally well to this system. These plants thrive when water is delivered consistently near their roots while the soil surface remains relatively dry. Dry surface conditions discourage weed growth while directing plant energy toward deeper root development. Fruit-bearing crops often produce larger harvests under this watering method because they experience less stress caused by irregular watering. Root crops, such as carrots and beets, can also benefit when jars are placed carefully so that moisture spreads evenly through the root zone. However, very shallow-rooted crops like lettuce may not fully utilize the deeper hydration pattern unless jars are installed closer to the surface. Understanding the root architecture of each crop allows gardeners to tailor the jar placement for maximum productivity. A simple, step-by-step installation process turns theory into a working irrigation system. Installing a clay jar irrigation system requires patience, but very little specialized equipment. The first step is selecting appropriate jars made from unglazed porous clay. Glazed ceramics will not allow water to pass through the walls, and therefore they cannot function as irrigation vessels. Once suitable jars are obtained, the gardener marks the garden bed to determine spacing. Holes are then excavated at each location deep enough to bury the jar while leaving the neck exposed above ground. The jar is placed into the hole and the surrounding soil is packed firmly around it. This step is critical because air gaps between the jar and soil reduce the efficiency of water transfer. After installation, the jar is filled with water and sealed with a lid. Plants are then placed around the perimeter of the jar's moisture zone. Over the following days, the gardener observes how quickly the water level drops inside the jar. This rate reveals how actively the surrounding plants are drawing moisture from the soil. In many cases, jars only need to be refilled every few days, even in warm climates. Ancient irrigation still offers practical solutions for modern gardeners. The beauty of clay jar irrigation lies in its simplicity. No electricity is required, no pumps or horses are needed. Gravity and soil physics handle the entire process. This is one reason the technique survived through centuries in water-scarce environments. Farmers working in harsh climates needed irrigation systems that used every drop of water wisely. By burying a simple clay vessel in the ground, they created a self-regulating moisture reservoir capable of sustaining crops through long dry periods. Modern gardeners, rediscovering this method, often find that it transforms the way they think about watering. Instead of flooding the soil surface repeatedly, they begin working with the natural behavior of roots and soil moisture. The result is a garden that requires less labor, less water, and often produces stronger plants. The deeper lesson hidden inside this ancient irrigation technique. At first glance, the clay jar irrigation system may seem like a simple gardening trick. It represents a deeper principle that appears throughout history. The most enduring technologies are often the ones that cooperate with natural forces instead of fighting them. By understanding how water moves through soil and how plant roots search for moisture, ancient farmers created a system that required almost no maintenance, yet delivered remarkable results. Modern technology can certainly enhance agriculture, but sometimes the most elegant solutions were already discovered long ago. Clay jar irrigation stands as a reminder that ancient knowledge still holds practical value for anyone willing to study it carefully. For those who enjoy exploring historical techniques that remain useful today, strategic clay jar installation offers a powerful example of practical ingenuity. A buried vessel, properly placed and protected with a lid, can quietly feed plants for weeks while conserving water that would otherwise evaporate into the air. In an era where water efficiency is becoming increasingly important, revisiting these time-tested methods provides both inspiration and practical results. If you enjoy learning about forgotten techniques, historical innovations, and practical systems that still work today, consider subscribing to the channel and sharing this guide with fellow history enthusiasts and gardeners. Knowledge like this deserves to be preserved, practiced, and passed on to the next generation.